In this video, we will talk about some of the techniques for problem solving and how problems differ from exercises. So the first question we should look at is, what do we mean by problem solving? I like a quote by G.H. Wheatley from about 1984, which states that problem solving is what you do when you don't know what to do. If you've ever been at an exam or some other location and you have a problem, you read it and you have absolutely no idea what's going on, you have a problem. This is essentially what problem solving is about. What you do when you don't know what to do. One of the reasons why many non-science majors end up taking a science course, even though it might otherwise not seem relevant to their major, is because science courses are really good at teaching problem solving. There's a difference between problems and exercises. An exercise is a question that you know how to solve. A problem is a question that you don't know how to solve. So let's look at an example of what might be a possible problem. Two trains are stopped on adjacent tracks. The engine of one train is 1,000 yards ahead of the engine of another. The end of the caboose of the first train is 400 yards ahead of the end of the caboose of the other. The first train is 3 times as long as the second train. How long are the trains, assuming that both are headed in the same direction? Okay, there was a lot of information in that particular question, so let's go back through and try to see if we can pick out some of the key concepts that we're going to need. So we have two trains. They are stopped on adjacent track. The engine of one train is 1,000 yards ahead of the engine of the other. Right, so let's say possibly engines are important. The end of the caboose, or the back, of the first train is 400 yards ahead of the end of the caboose of the other. The first train is 3 times as long as the second. How long are the trains? So we're trying to figure out how long they are. Okay, so the first thing that we should do is try to make some sort of a drawing, a graphical representation to help bring some of this information out so that we don't have to necessarily keep reading the problem. So we got two trains. Engine of one train is 1,000 yards ahead of the engine of another. So I'm going to just make a box, call this E1. That's going to be the engine of one. This will go to, I'm going to label C1 as the caboose for train 1. So this is 1,000 yards ahead of the engine of the other. So we got our second train, E2. Okay, and then the end of the caboose of the first train is 400 yards ahead of the caboose of the other. So that means that the second train, the caboose, is behind the first one. Okay, so we have something like this, and then the distance between the start of one train and the start of the other, this distance here is 1,000 yards. And the distance between the ends of the two cabooses is 400 yards. Okay, and then we also have that train 1, the first train, is 3 times as long as the second. So the length of train 1 is equal to 3 times that of train 2. So this is our train 1, this is our train 2. Okay, so one of the things we could try is looking at our length here between our two trains. So the entire setup from end here to end here is the same between the two. So we could set this up as an equality, just seeing how this is going to work out. So we're going to call T1 the length from the beginning of the engine 1 to the end here of engine of the caboose 1. So that distance is T1, and then the corresponding distance here, we're going to call that T2. So if we take T1 and we add 400 yards to it, that is going to be equal to the length of T2 plus 1,000. So 1,000 yards plus the length of T2. So we actually have two equations with only two unknowns, right? We have our equation right here, right? T1 is 3 times T2, and then we have an equality of T1 plus 400 is equal to 1,000 plus T2. So we can actually take our representation here, right, our equality of T1 is equal to 3T2, and replace this T1 with the value. So this would be 3T2 plus 400 yards is equal to 1,000 yards plus T2. Let's get all the T2s to one side and move all the yards to another. So this would be 3T2 minus T2 is equal to 1,000 yards minus 400. Okay, so this part here would be 2T2 is equal to 600 yards. And so if we divide both sides by 2, this cancels out, which gives us T2 is equal to 300 yards. Okay, so that actually gives us the answer for how long train 2 is. We now have to figure out how long train 1 is. Train 1 is 3 times that length from our equation that we have here. So T1 would be equal to 3 times that value. So 3 times 300 would be 900. And that actually answers our question. In the previous example, you might have noticed me doing a couple things while trying to solve the problem. Now, if you look into the theory of problem solving, you'll find a variety of different explanations for how people successfully solve problems, some of which are much more simplified than what is presented here. Some you will see have details including read the problem, draw a picture, write out mathematical equations, solve the problem, evaluate the answer, right? That is more what you would do if you were trying to solve an exercise. When you're trying to solve a problem using problem solving, which is again what you do when you don't know what to do, problem solving is a bit more complicated than just reading the problem, coming up with the answer. In the previous example, you might have noticed me doing a couple things. First, I read the problem, then I read it again. Successful problem solvers rarely ever read the problem just once. You read it the first time to get an idea of what you're doing or what the general idea is, then you read it again to try to confirm what you think or pull out some key information. Then you're going to write down what you hope is relevant information. In the example that I just did, this was essentially me going through, underlining some of the key components, and then using that to draw a picture, make a list, or write an equation or formula to help you understand the problem. So in the previous problem, I drew what the trains look like, wrote down the formula for the fact that the first train was 3 times longer than the second train, right? So that was drawing a picture, writing down some useful information. Then you try something. Now, in the example that we did previously, it was successful fairly early on, and so it wouldn't be what you would necessarily do for a very difficult problem. For a difficult problem, you might not get it on the first try, so you try something else. See where that gets you. Read the problem again. Try something else. See where this gets you. Test the intermediate results to see whether you are making any progress toward an answer. In the previous example, I did this when we were writing it down, and I looked at the equations we had and noted that we had 2 unknowns and 2 equations. When you have 2 unknowns and 2 equations, you are generally going to be able to solve for your 2 unknown values. read the problem again. When appropriate, strike your forehead and say, "son of a gun." Write down an answer, not necessarily the answer. Test the answer to see if it makes sense. Start over if you have to, celebrate if you don't. This is actually the general format for what successful problem solvers do when they are trying to solve a problem. You'll see that there's a lot of cyclic nature to it, where you go back and you read the problem again, read the problem again, read the problem again. When you are trying to solve a problem in this class and in any other class, don't think that you should be able to solve it by reading the problem once. You will often have to read it many, many times, particularly if it is a problem as opposed to an exercise. An exercise is something you know how to solve. A problem is something that you don't. So if you're trying to solve a problem, you should expect to read the problem description several times. Another key part is writing down or drawing a picture. Successful problem solvers will often draw pictures to pull out information from the problem to try to make it more visual. On problems where you're handing in your calculations, if you do not get to the actual full answer, but you show in your work proper problem solving, you will get partial credit for the work that you've done. So make sure that you show that you are writing down what you hope is useful information, drawing a picture to better understand what you're doing. Show that you are testing the results to see whether you are making any sort of a progress. Write down an answer, not necessarily the answer. Test the answer to see if it makes sense. This is a key thing that a lot of people skip over, and which results in incorrect answers. Sometimes you'll come out with an answer, but you should always evaluate it to make sure that it makes sense. A lot of times in chemistry, we're working with either very large or very small numbers. If you don't type them into your calculator correctly, you'll get answers that don't make much sense. So you should always test your answer to make sure that it makes sense, and this will give you a way of evaluating if you plugged it into your calculator correctly or not.